Hello students, this lesson is lesson 1-2, equivalent fractions. In this lesson you will understand what equivalent fractions are, and you will be able to find equivalent fractions in a few different ways. Equivalent fractions name the same amount using different numbers. In the example shown, there's the same size whole circle, but at first you have a fraction model representing 1/2. Then we go to 2/4. Notice, however, the shaded portion is exactly the same amount. Then again we have 3/6. The same amount is shaded, and 4/8. The same amount is shaded. When we have equivalent fractions, the same amount is shown using different numbers. When we go from 1/2 to 4/8, there are more pieces, but there's a smaller amount in each piece. We can use number lines to show equivalent fractions as well. The top number line is thirds, the middle number line is sixths, and the bottom number line is twelfths. Note, it's really important that you understand that these are all the exact same size whole. If we have 2/3, we can use the number line to show that 4/6 is the exact same amount because the distance it takes to get from 0 to 2/3 is the exact same amount of distance it takes to get from 0 to 4/6. What fraction in twelfths is equivalent to 2/3 and 4/6? If you said 8/12, you're exactly right because it takes the same amount of distance to get from 0 to 8/12 as it does from 2/3 and 4/6. We can also find equivalent fractions by multiplying and dividing. If we have the fraction 4/9, we can find another fraction that is equivalent to 4/9 by multiplying. As long as you multiply both the numerator and the denominator by the same number, you'll have an equivalent fraction. What that number is completely up to you. I'm going to use an easy one. Let's say that I want to multiply 4/9 by the multiplier, is what we call this, 2/2. This is okay to do because remember, 2/2 is the exact same thing as 1 whole. And multiplying any number by 1 whole gives you that same number back. So the amount will be the same, however, the numbers will be different. 4 times 2 is 8, and 9 times 2 is 18. 4/9 is equivalent to 8/18. We can use a similar method of finding equivalent fractions by dividing. Let's say that I have the fraction 21/56. As long as I divide both the numerator and the denominator by the same number, I'll get an equivalent fraction to 21/56. I'll divide both of these numbers by the divisor 7/7. Remember, it's okay because 7/7 is equivalent or the same as 1 whole, and any number divided by 1 would give you the same number back. We're just representing that same amount using different numbers. The top, 21 divided by 7, is 3, and the bottom, 56 divided by 7, is 8. 21/56 is equivalent to 3/8. When you work on your workbook pages today, you're going to see problems that are set up very similar to this. In the example shown, we are trying to find a fraction that is equivalent to 2/3 but has been broken into 6 equal pieces. Using a multiplier, we can figure out what that fraction would be. First, since we know on the denominator that 3 is what we're starting with and 6 is what we're ending with, we would ask ourselves, what do we multiply 3 by to get 6? And I know that that would be 2. Remember, whatever you do to the top, you have to do to the bottom. Whatever you do to the bottom, you have to do the same thing to the top. Since we multiplied by 2 on the bottom, I would multiply by 2 on the top as well. 2 times 2 is 4. So the fraction that is equivalent to 2/3 is 4/6. And I can show this on the number line. I know that this number line here on the 6, it starts with 0/6, and I know that this would be 1/6. This then would be 2/6, 3/6, and 4/6. 2/3 and 4/6 are directly on top of each other, so it takes the same amount of space to go from 0/3 to 2/3 as it does from 0/6 to 4/6, making these numbers equivalent. Another example that you'll see in your book is using that same method but dividing. Here we're given the fraction 10/15, and we want to know what we would divide 10/15 by to get 2/3. So you ask yourself, what do you divide 10 by to get 2? I know that that's 5, and because whatever we do to the top we have to do to the bottom, 15 divided by 5 should also equal 3, which it does. Then we can label our number line. Here, they've already shown 15ths, and they've already shown the jumps that you take to get there. 0/15 is where we'll start. 1, 2, 3, 4, 5/15. 6, 7, 8, 9, and 10/15. You can see that these larger partitions, this number line was broken into thirds. 0, 1, 2, 3 equal pieces, and it took 2 of those 3 equal sized pieces to equal 10/15. Oftentimes you'll just be told to list equivalent fractions. To find fractions that are equivalent to a given fraction, all you have to do is pick any number in the world and multiply the bottom and the top of the fraction by that same number. So if I want to find 5 fractions that are equivalent to 3/5, I'll start off by writing 3/5. I'm first going to multiply 3 and 5 by 2. When I do that, I know that 3 times 2 is 6, 5 times 2 is 10. 3/5 is equivalent to 6/10. Now I'll find another one. This time I'll use the multiplier 3. I'm going back to 3/5, but I could just continue to multiply the new fractions and I'd still get a fraction that's equivalent to the original. 3 times 3 is 9, and 5 times 3 is 15. This time I'll use the multiplier 4. 3 times 4 is 12, and the denominator 5 times 4 is 20. And then for the last one, I think I will use a multiplier of 100. Any number multiplied by 100 is that number with 2 zeros on the end of that number. 3 times 100 would be 300, and 5 times 100 is 500. There's 1, 2, 3, 4. So actually I need one more, and for my last one, I think I will multiply by 1,000. Just like multiplying by 100, any number times 1,000 would be that number. This time it would have 3 zeros annexed on the end. So 3 times 1,000 is 3,000, and 5 times 1,000 is 5,000. What we have here is a chain of equivalent fractions. Here's a couple of real-world equivalent fractions problems. Jackie saved 2/5 of all the money she earned over the summer. How much did she save after earning $25? Well, if she saved 2/5, that means that we're going to start with 2/5 as our original fraction. 2/5 means that she saved $2 out of every $5, except this time we're asked how much after $25. 25 would be the total amount that she earned, and what we don't know is how much that she actually saved. So we'll use an equivalent fraction. What do we multiply 5 by to get 25? Well, 5. If we multiply the bottom by 5, we do the same exact thing to the top. 2 times 5 is 10. So after earning $25, Jackie saved $10. How much did she save after earning $50? Well, we'll start with that original fraction of 2/5, except now we're going to find the fraction that's equivalent to that in 50ths because she earned $50. What do we multiply 5 by to get 50? Easy, 10. If we multiply the bottom by 10, we'll do the same exact thing to the top. 2 times 10 is 20. So after earning $50, she saved 20 of it. And then the same question, after she earned $100, how much did she save? We'll start with 2/5. Make an equivalent fraction out of 100 because 100 would be the total. What do we multiply 5 by to get 100? 20. So what would we do to the top? Same exact thing. Whatever you do to the bottom, you do to the top. Whatever you do to the top, you do to the bottom. 2 times 20 is 40. So after earning $100, Jackie had saved up $40. If you have 3/4 of a cup of flour, how many twelfths do you have? Well, we want to find an equivalent fraction. We know that 3/4 is equivalent to some amount of twelfths. What do we multiply 4 by to get 12? 3. Whatever you do to the top, you do the same thing to the bottom and vice versa. So 3 times 3 would be 9. If we have 3/4 of a cup of flour, we have 9/12 of a cup of flour. Same exact amount, just using different numbers. If you have 9/24 of a cake, how many eighths do you have? Find an equivalent fraction. We know that 9/24 is the amount. We want to find a fraction equivalent to that, except it's going to be in eighths. What do you do to 24 to get 8? Well, I know I'm not multiplying because I'm getting smaller, so I need to find the divisor. 24 divided by 3 is equal to 8. So whatever we do to the bottom, we do the same thing to the top. 9 divided by 3 is 3. If we have 9/24 of a cake, we have 3/8 of a cake. Same amount represented by different numbers.